All right, let's talk about cross product. All right, this one is section 2.4. Okay, what is cross product? Cross product is like, if you look at the cross product, this is how you write down vector u cross product to v, and you're gonna put I, j, k. These are the standard unit vector, and then you're gonna put u first. That's a u, and this is a v vector in the second one. So if it is v cross u, then you're going to put v on the second row, and then u on the third row. Okay. All right. So the how it goes is, so you're going to put I first, I here, and then you're going to take this. You think about this as a matrix. You're going to multiply these two guys, u2 times v3, u2 times v3, minus this guy, okay, u3 times v2, u3 times v2. Okay, the same process, we're going to use it for j. So but before that, second one, you're going to put a negative here. You guys see the negative, second one negative, and you're going to put j there again. Let's go back again. I'm going to show you what the second one looks like. So j is going to be there, so the vertical that j vector there, times this parenthesis, which you're going to take it out of these two guys, right? These two columns there. So again, you're going to multiply u1 times v3, u1 times v3, minus u3 times v1, u3 times v1, and that's going to be that. Okay. I don't know. You can see over here too, this is the second stage. Now if you look at the third k, let me erase this again. Look at that k. So you're gonna cover this k and this guy, and what's left is this guy, right? And that's what it's gonna copy over here, right? The same thing, we can do that for I and j too. So, and then again, you do u1 times v1, u1 times, sorry, v2, u1 times v2, minus v1 times u2, or u2 times v1. All right, and then you're going to k. So the final results is a vector here. Okay, just keep in mind the final results is a vector. Okay, it's going to be vector. So your final results is a vector. So cross product is it's going to yield a vector. Remember that. And then the dot product yields a scalar, right? It's just a number. Okay, now what is this vector signifies? All right, so if you have a u vector this way and v vector this one, u v, you have a vector like that, then the cross product vector is going to be perpendicular to both of them, or orthogonal to both of them, right? So let's see if I draw that one in a color. It's going to look like that, or is going to look like in the bottom. So this is going to be like, I know this is a 3D, so if you look at that, it's going to be 90 degree here, and this is going to be 90 degree here too. Remember, this is in 3D, right? So if you think about like this is a paper, this is a paper, and you have two vectors like that. So the cross product vector is going to be, it's coming out from the paper or it's going down from the paper, right? And it follows that right hand rule too, right? Just look at that, and if you have any question, let me know. I'm going to give you the example here now. Okay, but before that, let's go on here, and then let's see what is this what's the one of the application. All right, so if you look at here, if you want to find the area of the parallelogram, so this is your u, that's your v there. Okay, if you want to find the area, so what you're going to do is you're going to multiply u times the height, isn't it, the parallelogram? That's how you get the length times width, length times the height or width, right? So width is, in this case, is not a v, it's not a v, but the component of v, right? The component of v is going to be like this one, we call it v sine theta. Remember that. If it is a horizontal component, like if any have a v is like this is your vertical component, and this is your horizontal component, right? Remember that. This one is your V cosine theta, and this is your V sine theta. All right, so this height width is going to be happen to be V sine theta. So if you want to calculate that, multiply the magnitude, the length of U times V sine theta. V is also a magnitude, sine theta gives you the area of the parallelogram. All right, this parallelogram, and then that is same as the magnitude of the parallelogram. Okay, so look at that. And one more thing I'm going to do, and then maybe I will do an example in a different video. Okay, so one more thing is triple scalar product. What is triple scalar product is, now remember that we have three vectors u, v, w. We have three vectors u, v, w. U dot v cross w, right? You cross product of this one dot with u. Or it can be, you can write down u cross v and then dot with w. You could do that too. All right, you're gonna get the same results. So, but this is gonna be, if you wanna write down that looks like this. All right, it's the setup. Instead of I, J, K here, you're gonna put that u there. All right, now if you calculate this one, the results is gonna be just a number, right? And that is the volume of the parallel piped. All right, so that means, think about this way. This is like volume, right? So it has to be 3-dimension. Let me draw the first box. All right, it's a parallelogram. Now think about, like, I want to draw the vectors. Let's see, this is your u, v, and you could have a w here. All right, so that makes the volume of this parallel piped. Okay, so I will give you example in the next video. All right.